You said we couldn't use the butt cheeks.
Hey, but I went to 6
You can.
Oh no, he said.
Oh,
What?
he's wrong.
Yeah.
What?
Yeah. Yeah.
I should never listen to that.
I wouldn't either. All right. So, how do I factor this bad boy? Because it says number 1, factor the polynomial equation. Go ahead. Say what you got. Don't say the parentheses. I get that part.
Okay, x squared minus 9 and x squared minus 4.
Okay. Do we all agree with x squared minus 9 and x squared minus 4 for the factored equation? Do we all agree with that as our answer for the factored equation?
No.
No. Nobody should agree with that. Okay? Because why?
You have to keep going.
You have to keep going. What is the answer then?
X plus 3, x minus 3, x minus 2, x plus 2.
And let's touch this one. Oops, that one a little too much. I just can't stop. Okay, so that is the fully factored, or as we were saying last week, the completely factored, or factored completely, polynomial equation. Okay, now question number 2. Write the roots of the polynomial equation. How do I find the roots of the polynomial equation? Set all of my factors equal to 0. So I would go x plus 3 equals 0. So x here would be negative 3. X minus 3 equals 0. So x would be 3. X plus 2 equals 0. So x equals negative 2. X minus 2 equals 0. So x equals 2. So my 4 answers, because I need to get 4 answers, are plus and minus 2 and plus and minus 3. Now, they were asking earlier, could we just circle all 4 of those? Sure. If you want to clean it up and make it the plus and minus, that's fine. Okay. Now, what are roots? Answers, solutions, zeros. If we wrote them in point form, then they would be x-intercepts. They're also factors. Yep. Okay. They're all of those things. Okay. They're all of those things. All right. Now, the reason I say that is because if we go to number 3, number 3 says graph the polynomial equation. I don't have a graphing calculator. How are we going to do it? What you got, Max?
Plot the zeros that you had.
Plot the zeros that we had, because those zeros are the answers, the solutions, the roots, the x-intercepts, the factors, whatever we want to call them, right? Okay, so if I go about plotting, that would mean I'd have an x-intercept at negative 3, at negative 2, at positive 2, and at positive 3. Now remember, my equation was x to the 4th minus 13x squared plus 36 equals 0. But what I'm really graphing is f of x equals x to the 4th minus 13x squared plus 36. What can you tell me about f of x? Allie?
Like both of them would be pointing in the same direction.
Because
That's
not
where like the largest root is
the largest root. The largest, well, the degree is even, so that means that the largest, the E word, exponent. Exponent. Okay, the biggest exponent is even, so that means that the left and the right side are going in the same direction. Okay, Joe?
This function will be going in the upward direction because x to the fourth is positive.
Not x to the fourth is positive.
But your leading
The leading coefficient is positive, so on both the left and the right side, it's going to be going up. So, just, what do you got, Max?
You can tell that it's going to cross the y-axis at 36.
At 36. Okay, why do you know it's going to cross the y-axis at 36?
Because of the plus 36 without an exponent.
Because if I put in 0 here and I put in 0 here, those two terms cancel out, right? So that leaves me with a y-intercept of 36. Yes. Okay. So back to what Joe said then too is I'm going to be up here and I'm going to be up here, right? Okay. So my function here is going to come down from on high, go through -3, turn, come back up through -2, go through my y-intercept, which Max said was 36, turn, come down through 2, turn, go up through 3, and off that way. So it looks kind of like a W, right? Now, I'm not concerned until Wednesday about how low this function goes. Okay? Not concerned at all about that. We'll figure that stuff out on Wednesday. Okay? What I am concerned about today is I am concerned about when the function, oops, I gotta go back, hold on, I gotta go back to the computer because I remembered that this was goofy in the last class. I go back here, I gotta move this. Yeah, this comes along for the ride too. Oh, hold on. I should control group that. That's why I was getting fits. Despite all my rage, I'm still just a rat in a cage. Eh? It's actually a song. Yeah. Okay. All right. So I won't click off of there. Now, there it goes. All right. So what I'm concerned about today is when my function is greater than 0, or when my function is less than 0. So, just based solely on my graph, how can I tell when my function is greater than 0? When it's above the x-axis. Okay? My function is greater than 0 when it is above the x-axis. Flip it around. When is my function less than 0 then? When it's below the x-axis. Okay. Now, what this is interval notation. Okay. So when you're dealing with interval notation, you are just looking at x values. I don't give points I just give x values. It's a range that those x values produce in this first line, produce where the function is above the x-axis. In the second line, x values that produce the function below the x-axis. Okay? So, I like to work left to right on the radio dial. Okay? Alright? So, I'm starting way over here on the left and I'm at negative infinity. Am I above or below the x-axis? I'm above. So that would be above. Then I work my way to the right and I get to negative 3. What happens at negative 3? It doesn't dip below, it
Reaches it.
crosses over, right? Okay, that's my crossover point. So I'm positive all the way up to negative 3, but then it crosses over, and so now I'm below. And then I work my way to the left. Now I come to negative 2. What happens at negative 2? It crosses back. So I stop being negative, and I again become positive. And then I keep working my way to the right. And I get to positive 2. And what happens at positive 2? It crosses over again. So then this one stops being positive and it starts being negative again. Then I work my way to the right and I get to positive 3. What happens there? Crosses over again, so it stops being negative and it starts being positive and it stays positive for the remainder of infinity. Okay? Now, that same scenario given in interval notation, that is in interval notation, in inequalities, f of x would be greater than 0 when x is less, whoa. I just moved, okay. When x is less than negative 3, or that u, this u right here, or right there, or right there, that u is for union. It means or in interval notation, so I'm in or case. Or negative 2 is less than x is less than positive 2. Or x is greater than 3. F of x then would be less than 0 in the cases of negative 3 is less than x is less than negative 2, or 2 is less than x is less than 3. Me, I prefer interval notation. To me, it's cleaner, it's neater, less writing actually. Okay? But unless it specifically says in interval notation or in inequality, okay? Depends on what you want to do. They both mean the exact same thing. Okay? With it? We're going to flip to your textbook now. We are going to be on page, maybe. Why won't it move? We're going to be on page 406. Law enforcement. Love the names that the book comes up with. Law enforcement is a small landscaping company, has a profit model that can be represented by the function P of X. I'm not even going to read off what P of X is. You guys can read. Okay? All right? Where profit in thousands of dollars here, okay, so profit here is in thousands of dollars, is a function of time and years the company has been in business. Let's analyze P of X represented on the graph. So there is the graph of P of X. Okay? What can you tell me about P of X, the graph? Max.
Negative degree.
Can't have a negative
Or
degree.
no,
Negative lead coefficient. Does that make sense from what P of X is? Okay. What else can you tell me? Okay, what else can you tell me? Think about the context of the problem. What is it modeling? All right, what'd you guys come up with? What you got, Andrew? So what else did you guys come up with about P of X? What do you got?
We said that there was one absolute maximum.
Okay, what else did you come up with? Okay, keep going. I like you guys are doing a good job analyzing. Not really relating it to the context of the problem. Okay? You guys are just merely looking at the function. I don't like that one.
When it crosses the x-axis, then we see
No, that does not make sense to me. If I were looking at this one, if I'm looking at this, if I own law enforcement, what is this graph telling me? It changes every year.
Yeah.
Okay, because it's in years. What is this telling me? Specifically, those three blue boxes.
The function is below the x-axis or below the 0 line.
So what is that telling me?
That you're losing money at those
Down
points.
here, I'm losing money. Anytime that I'm down here, I'm losing money. So how long do I need to be in business before we make dollar bills, y'all? Year and a half-ish? I think it actually estimates it at 1.4. Okay? So I'm losing money the first 1.4 years that I'm in business. Then what happens? Then I start making a profit, right? Then what happens? What do you got? What happens at 4 years?
Then you start losing monies again.
We either probably reinvested it in something, or another business moved into town and we lost some money. Okay? All right? Put it away. Okay? And then what happened?
Business went out of business.
And now we're making money again starting when?
6 years.
6 years we start making money. Okay? And then what happens?
Stock collapse.
Okay? Okay? Never know. Another big business comes into town. Maybe we get a drought. Okay? Something like that. Okay? So we lose a ton of money then after that. Okay? So we're making money above the x-axis. We're losing money below the x-axis. Okay? What they did here, or what the book did in this line, is they just took and they just broke down the x-axis. Okay? And so over here, we're losing. In here, we're losing. And over here, we're losing. But in between these, we're making money. Okay? So in interval notation, okay, we're losing in those three. So from now, in interval notation or in inequality notation, do I go to negative infinity? First day?
On Monday, yeah.
Never had a conflict on Mondays.
I always get conflict. I just always put it down.
News to me. Okay. Do we go to negative infinity?
No.
Why not? When do we go to? What's the leftmost number we would go to? 0. Okay? Because that would be when we started our business. Okay? So from 0 to about 1.4 years, we're losing money. Then we start making money. Okay? Then at 4 years to 6 years, we start losing money again. And then after 8.3 years, we start losing money again. So the interval notation for this same losing money would be from 0 to 1.4, unioned with 4 to 6, unioned with 8.3 to infinity. Because now I don't know how far out we're going. Okay? Probably not going to stay in business very long after 8.3 years on this profit model. Because I don't want to be losing negative infinity dollars 20 years down the road. Okay? Okay? With me on that. Okay? What I'd like you to do now is I'd like you to go back to your the white sheet that I gave you. Okay? If you go back, oh wait, I forgot we got to analyze it, but that's okay. We pretty much analyzed it already. Why were the points changed to open circles? Because we're talking profit, and at 0 you're not making a profit, but you're not losing a profit. Circle the parts of the graph where it's less than 0. Okay, we did that. Those are those blue boxes. Draw a solid box around the segment where it's greater than 35,000. That would be up here. Okay, so that would be from like 2.1 to 2.6. Okay. And what else? Come on now. Come on. Work for me, computer. Okay? So now, on the back side of the white sheet, I want you to answer those 4 questions. Give it to me in interval or in inequality. Alright, so P of x is less than 0 when it's below the x-axis, correct? So on this first one, that would be from -2 to +2. P of x is greater than 0 when it's above the x-axis. So on this one, that would be from negative infinity to negative 2, unioned with 2 to infinity. On this one, P of x would be less than 0 from negative infinity to negative 2, unioned with 0 to 3. Again, I'm just looking at x values. These are not points. These are interval notation. They look like points, yes, okay, but they are not points. Okay? P of x is above the x-axis from negative 2 to 0 and from 3 to positive infinity. Good on those two. On this bad boy, okay, less than 0 from negative infinity to negative 7, unioned with negative 2 to 1, unioned with 6 to 9. It's above the x-axis then from negative 7 to negative 2, from 1 to 6, and from 9 to infinity. Last one. Is it ever negative? No. So that would be the empty set or none. Okay, one of the two. Okay, and when is it above the x-axis? Always, right? Okay, except at the 2's, right? Okay, so that would be from negative infinity to negative 2, unioned with negative 2 to 3, unioned with 3 to positive infinity. Okay? Now, if this were greater than or equal to, then we could be equal to 0, right? So then our interval would be from negative infinity all the way to positive infinity. And we'd write that out as our all real numbers. In interval form, all real numbers is negative infinity to positive infinity. Okay? Just wait. Don't be rude. Okay? Your homework tonight, which is due tomorrow, is simply doing more problems like this. Okay? Where you've got a factor, find the zeros, then using your knowledge, which we were all talking about, graphical knowledge of degrees and lead coefficients and all that stuff, okay, to find where the graph goes. And then, after you make the graph, then it's asking you, when is it above the x-axis? When is it below the x-axis? When is it above the x-axis? When is it below the x-axis? Okay? Am I done? According to Maddie, I'm done. So, have a good day.